year and a half ago that got over 600,000 views. However, a couple of things have changed with Unreal and I also made many improvements to the workflow, so this will be the definitive Unreal 2D video for beginners for 2024 and onward. For this tutorial, I'll use Unreal Engine 5.3, which is the current version. But if you watch this video at a later time, you should also be able to use any version newer than 5.3 as well. In the project browser, click on Games, and here we have a bunch of different templates. Sadly, there is no 2D template with Unreal Engine 5, and the ones you see here are custom templates I made by myself. If you're interested in these, there's a link in the description where you can get the basic template for free and the 2 advanced templates as a patron. But for this tutorial, I want to show you how to make a 2D game from scratch, so let's use the blank template and leave all of the settings on the right as they are by default. We want this to be a blueprint project for desktop with the maximum quality preset and no ray tracing, and also no starter content. Then give the project a name and click on Create. Once it's done loading, you can see this huge open world map, which we're not going to use. We want to first create a small 2D stage which our character can stand on. Click on File, New Level, and select the empty level and click on Create. We don't want to have any lighting or sky sphere, so this is perfect for making 2D stages. To make sure the stage doesn't disappear, we'll have to save it. Click on File, Save Level As. In the content folder, create a new folder called Maps. Change the name of the map to map_2D and save. We now want to set this as the default map. Go to Edit, Project Settings, and on the left side click on Maps and Modes. For the editor startup map, we now want to select this map_2D. And also for the game default map, we want to select map_2D. This just makes sure that this is the first map which is loaded when we open up Unreal Engine or make a build of the game. One more important setting I want to change right now before we import assets is the pixels per unit setting. By default, this is 1.0, which means that 1 pixel for a sprite is 1 Unreal Engine unit, which is 1 centimeter. In most cases, this is much too small though, and since our character is 48 pixels tall, it would only be 48 centimeters tall in the game, which is way too small for a human. This would cause some issues with settings such as the step height and would allow us to teleport up and down ledges, which is something we definitely don't want. I believe making the character about 3 times as tall should suffice and make it about 145 centimeters, which is in a reasonable range. And if we type in 0.33 here, that will achieve the effect of scaling up our pixel art by 3. Now for all of the assets we'll import and create after this, the new pixels per unit setting will be applied. The asset pack we're going to use for this video is Legacy Fantasy by Anokolisa, which is completely free and distributed under a CC0 license. Since the asset pack is huge and has many things we're not going to use, I prepared everything for easy usage with Unreal Engine and made a repack of the files. Please download this from the link in the description to follow along. This link will lead you to a Patreon post where the files are hosted, but everybody can download these even if they're not a member, so don't worry. Just click on it to download the zip file. After that, you'll have to right-click the archive and unzip the files. Here we have the character folder, which has the sprite sheet, and the environment folder, which has a few tile sets. Back in Unreal Engine, let's prepare a folder for this. Open up the content drawer and right-click, create a new folder called Paper Assets. We can now just select both the character and environment folder and drag them into our Unreal Engine window. This should work out for most of you, but a few people might have some trouble with this and are unable to drop the files into Unreal Engine. In that case, you can try using the import button on the top left of the content drawer, which usually works around that issue. Now that we have all of our textures in Unreal Engine, let's have a look at the environmental assets. If you double click the T_tiles main texture and zoom in, you can tell that something is off and it looks very blurry. This is because the default settings for textures introduce texture filtering and other settings that don't work well with pixel art. To work around that though, we only have to right click the texture, go to Sprite Actions and apply Paper 2D Texture Settings. This will update the settings to be ideal for pixel art, and you can see that when we zoom in. Select all of the other environmental textures as well by holding Shift and clicking all of them, and apply the Paper 2D Texture settings to them as well. To use these textures with a tile map, we first need to convert them to tile sets. Let's start with the one on the right, which is T_tiles main, and right click it. Go to Sprite Actions and create tile set. Double click the newly created tile set to open it up. Here in the tileset editor, there are only a couple of things we have to do before we can use these tiles in the game. The first thing we need to figure out is the tile size. We can see here on the right side that it's set to 32 by 32 by default. However, if we click around on the left side, you can see that the size of the square doesn't really match the tiles themselves. Sometimes the asset creator will mention the tile size, but other times you'll just have to use some trial and error to figure it out by yourself. For this asset, I know that the correct size is 16 by 16, so we can just type that in. Now that we have the correct tile size, the only thing left to do here is assigning the collision to the tiles that need it. Let's start from the top left. In the case of this asset, we actually don't want to assign collision to the topmost grass layer, because we want the character to nicely stand on top of the grass and not float above it. So let's assign collision starting from the second row. We can simply click on Add Box to add a box collision here. On the right side we could also make some adjustments, but the default is fine here. Let's click on the next tile and also add a box here. The problem we have now is that it's quite hard for us to tell what we've already assigned collision to and what we still have left to do. We can click on colliding tiles on the top left to show what already has collision. And now let's just continue adding box collisions to this one platform. Click it and click. In the content drawer, go to Paper Assets and Character. So fold out over there, actually open it up. Pretty good size and almost a bit of flick on the wall. Slightly back start, we can see that the character nicely appears in front of the platform. We say this won't work and also good by the right a while all up nice. First look for motion blur and turn this off. This can look very cool in 3D games, however blurriness doesn't go well with pixel art. Then look for anti-aliasing, and for the anti-aliasing method select none. Anti-aliasing is a technique that removes jagged lines, however again for pixel art this is something we don't want. Next look for auto exposure and turn it off. Also set the auto exposure bias to 0. Next we want to look for global illumination and set the dynamic global illumination method from lumen to none. Lumen is the new global illumination system introduced in Unreal Engine 5, however since our 2D stage won't have any lights, there is no benefit to using this. Then look for reflection method and also set this from lumen to none. Next look for shadow map method and set this from virtual shadow maps to for our level. To create cannot set and 3D objects, so there is no benefit to shadowing technique for 3D objects, but again we don't have any lights and 3D objects, so there is no benefit to using this. All of the other settings we cannot set in the project settings, but have to create a post-processing volume for our level. To create one, we can click on the add icon here, volumes, and click on post-process volume. Just so we don't lose track of it, we want to put it to the 0 where to find effect and set infinite extent unbound to true. This means it will affect our entire stage regardless of size and position. Now we can take care of the remaining settings. Look for EV100. Both the min EV100 and max EV100 affect the auto exposure and can make the brightness of our sprites inaccurate. We just want to set both of these to 0.0. Next, look up vignette intensity. This creates a darkened rim around the edge of the screen, which is something we generally don't want for 2D games, so set this to 0.0 as well. Next, look for expand gamut. This will affect the colors of your sprites and might make them look unnatural. Set this to 0.0 as well. Lastly, let's look for tone curve. This tone curve amount will again affect the colors of your sprites. In some cases this can look quite good and give the image. And now our 2D game looks a lot more peaceful. You always paste this post. We want to control the character and set up the camera. Know which pawn we want to possess. Open up the content drawer, go to the blueprints folder and write as the parent. This is a full-on blueprint which we can use in many different ways. However, for now we only want to look at the right where it says classes. And for the default pawn class, select our BP_player to let Unreal know we want to control this character. But now if we press play, nothing has changed because we also need to let Unreal know that we want to use this game mode, m_platformer. Click on Maps and Modes, For the default game mode, we want to select our GM_platformer. Now if we start the game, you can notice that something is very different. We are now falling and still don't really see what is going on. What is happening here is that Unreal Engine spawns a new instance of our BP player in our current position, however we want to spawn on top of the stage. Select the player we currently have here and hit the delete key on your keyboard to delete it. Then click on the plus icon, go to basic, and look for player start. Drag it into position, but we still don't see our character. If you click on eject though and move around the camera yet, so it instead puts us in this while the capsule is selected. While the spring arm is selected, click on add again and add a camera. Now we want to change this to a sideways view. Select the spring arm, go into rotate mode, and drag on the blue axis by -90 degrees. So we now look at the character from the front. Now when we start the game, we can finally get a good look at our character. The front. Axis by -90 degrees. Get a good look at our character. First of all, we want to go to the camera and set the projection mode from perspective to orthographic. The effect of the look states without the camera, we cannot use the target arm length on the spring arm anymore. Instead, on the camera, we can now change the ortho width. The wider this is, the further away the camera will appear. Let's set this to 700. And you can now see that the camera appears further away. Wait this. Test and deactivate this. If this is active and something is between the camera and the player character, it will forcefully zoom in. If you're making 3D or 2D/3D hybrid games, this might be useful in some cases, but for 2D only games, this will often just lead to bugs and confusion and allow the character to move and jump. Since Unreal Engine 5.1 might be in the end, right-click and create a new folder called Up. Execute binds the actions are called this, but the only one which is correct for an action, that is the case for a regular button. Create another input action called IA_move. Open this up, and here we actually want to change the value type. The move action can be executed analog -1 for left, value type of axis. Go to input and create an input mapping. Double click to open it up into a button. Where it says mappings, click on the plus icon and then on the caret to expand the menu. Click where it says, and here we can press we have to do and the D. And for the other thing though, and we need to differentiate between them for walking left and right. Since we selected a 1D axis float here, we need to flip around the input for left and the A key. So here we can go to modifiers and add the negate modifier. By default, an axis 1D will point to the right, so for D we get the value of 1, but a context and then also what code to execute when we trigger. We need to activate, drag off from the return value and cast to player controller. Connect the line to begin play. From the player controller, drag off and look for subsystem and get the enhanced input local. From the player controller, drag off and look for subsystem and get the enhanced input local player subsystem. But again, if still and here to activate the input map in context on begin play. Right click and get controller. Drag off from the return value and cast to player controller. Connect the line to begin play. From them and get the enhanced input local player subsystem. Here drag off and look for add mapping context. And then connect the lines. The sign would work. You can just move to the side a bit, right click and look for IA jump. We can expand the print string that says jump. Just and here we can drag off from trigger and just go back and port on to when this is just from started and look for the jump function. Then drag off from completed and look for stop jumping. And this is the default setup for jumping and all it takes to make the character jump when we press space. Let's get rid of drag off. Here we connect the axis value to the scale value. And we need to set the world direction. If we go back to the map and select the player start, we can see that the red arrow is the direction we want to go. Value in the X. We can walk magic team. These are things that are need for us to reinvent. Setting up between the idle, walk, and jump animation. Since this will make the game feel much more complete. Open up the BP_player and look for the tick event. The tick event will be fired off on every single frame and is the best way to keep something like an event. The tick event will be fired off on every single frame and is the best way to keep something like an animation state up to date. First, we just want to switch between the idle and walking state, and to determine if we need to switch or not, we only need to know if the character is currently moving or stationary. To do that, we can just right click and get velocity. And then look for vector length. We don't really care about the direction in this case, and vector length will simply give us a value of 0 if we're not moving, or a positive value if we are moving. So here we can simply check for greater than 0. Then put a branch here, which basically is an if-else statement. We can simply check for greater than 0. Then put a branch here, which basically is an if-else statement, if you're familiar with other programming languages. Then we can drag out a reference to sprite, which is actually the flipbook component. And here we can then call set flipbook to sprite. Then we can drag out a reference to sprite, which is actually the flipbook component. And here we can then call set flipbook. And set the new flipbook to fb_player_run. Then connect this node to the true output of the branch. You can also double-click these lines to create reroute nodes to organize the blueprint a little bit. Then we can just select all of this, Ctrl+C to copy, and then Ctrl+V to paste, and connect it to the false case. Here for the new flipbook, we want to select the fb_player_idle. And now we can just go back to the map and press play to check this out. We are now correctly switching between the walk and idle animation if we are moving. Next up, we want to put in the jump, rise, and fall animation as well. First, we want to clean this up a bit, and we can select all of these nodes we use for switching between the run and the idle. If you can't select all of them at once, you can hold Shift or Control to get them in multiple goes. Then right-click one of them and collapse to function. Call this update animation and move it over. Now double-click to open it up. Then right-click one of them and collapse to function. Call this update animation and move it over. Now double-click to open it up. This still does exactly the same thing and collapse to function. Call this update animation and move it over. Now double-click to open it up. This still does exactly the same thing, but it's encapsulated nicely and a lot easier to maintain. Now at the place before we decide between the idle and run, we want to open up some space. Here we now look for is moving on between. It's encapsulated nicely. Now double-click to open it up and move it over. Now double-click to open it up. This still does exactly the same thing, but it's encapsulated nicely and a lot easier to maintain. Now at the place before we decide between the idle and run, we want to open up some space. Here we now look for is moving on ground, which is a method available on the character movement component. And here we can add another branch. Connect it, and then also connect the true output to what we were doing before. Because if we are moving on the ground, we need to decide between the walking and idle like we have been doing before. If we are moving, also connect the true output to what we were doing before. Because if we are moving on the ground, we need to decide between the walking and idle like we have been doing before. We are moving, also connect the true output to what we were doing before. Because if we are moving on the ground, we need to decide between the walking and idle like we have been doing before. Now for the false case, we want another branch. And here we want to check if our character is currently going upwards or downwards. For this we can just get velocity. Right-click the return value and split struct pin. Now we need to know if we want to use the X, Y, or Z. Again, if we go to the map and click on the player start, we use the X, Y, or Z. Again, if we go to the map and click on the player start, we know that the blue arrow is up or down. And if we drag this around, we can see that the Z value is the one that changes. So back in the blueprint, we can then check for the return value Z and see if it's smaller than 0. This means that we are falling down or descending. So here we can copy paste this sprite and set flipbook. And for the new flipbook, select the FB player fall. Then copy paste this again. And in the false case, play the FB player jump rise. And now you can see that we can properly switch between the jump rise and the falling animation. A nice little trick to make the transition a little bit smoother is to not check for smaller than 0, but check for something around -100. That way we don't switch animations directly at the apex of the jump, but after descending a little bit. This just makes it feel a bit more natural in my opinion. And this is all it takes to set up animation switching for your paper 2D flipbooks. For simple things like we did now, this method works just fine. However, once you make more complicated games with a lot more animations, this can be a bit hard to manage. For that reason, somebody made a free plugin called PaperZD, which adds support for animation graphs that make handling animation states much simpler. This is definitely something that will make your life a lot easier when making 2D games with Unreal Engine. I actually made a full 12-hour course about 2D game creation with Unreal Engine, in which I teach you how to create 4 awesome games. We start out slowly by creating a simple quick draw minigame, then move on to creating a classic arcade masher game, and the last 2 projects will make use of the free PaperZD plugin and will go into detail on how you can set it up and get the most out of it when making more complex games. We'll use this to create a platformer game with enemy AI and gimmicks, and lastly to also create an action platformer in a 2D 3D hybrid style that includes melee combat and some Metroidvania elements. So if you're interested in mastering Unreal Engine 2D, check out the discount link in the description. The next thing we want to do is make our character turn left and right when walking, because now we're always just pointing to the right. This is actually quite easy to do. Back in the BP_player, we want to go back to the event graph and look for our IA move event. After the add movement input, we want to right-click and get controller. Then drag off here and set controller. After the add movement input, we want to right-click and get controller. And look for our IA move event. After the add movement input, we want to right-click and get controller. Then drag off here and set control rotation. We can drag off from new rotation and look for select. Use the utilities select here. This acts very similarly to a branch, but in situations like this, it can be a bit easier to use. This will now basically just let us pick between 2 options for setting the character's rotation. And how do we decide this? Well, the action value will be something negative for left and something positive for right. So we can just drag off and check for greater than 0 and plug this into the index. Let's start with the true case. Drag off here and look for Make Rotator and select the one all the way at the bottom. If this is true, we want to point right, so for this we can just leave everything at 0. For the false case, again, make Rotator. For the false case, again, make right, so for this we can just leave Rotator. Let's start with the true case. Drag off here and look for Make Rotator and select the one all the way at the bottom. If this is true, we want to point right, so for this we can just leave everything at 0. For the false case, again, make Rotator. When moving left, we want to turn the character by 180 degrees on the Z-axis, so here we can just put in 180. Now if we start the game and walk right, everything is fine. But if we walk left, you can suddenly not see the character anymore. Right, everything is fine. 80. Character by 180 degrees on the Z-axis, so here we can just put in 180. By 100, so we can just Rotator and plug this into the index. Let's start with the true case. Drag off here, check for greater than 0 and plug this into the index. Let's start with the true case. Drag off here and look for Make Rotator and select the one all the way at the bottom. If this is true, we want to point right, so for this we can just leave everything at 0. For the false case, again, make Rotator. When moving left, we want to turn the character by 180 degrees on the Z at 0. If the select the start with the end for right, basically a black. We can drag off from new rotation and look for select. Use the utilities select here. This acts very similarly to a branch, but in situations like this, it can be a bit easier to use. This will now basically just let us pick between two options for setting the character's rotation. And how do we very similarly to a branch, but in situations like this, it can be a bit easier to use. This will now basically just let us pick between two options for setting the character's rotation. And how do we decide this? Well, the action value will be something negative for left and something positive for right. So we can just drag off and check for greater than 0 and plug this into the index. Let's start with the true case. Drag off here and look for Make Rotator and select the one all the way at the bottom. If this is true, we want to point right, so for this we can just leave everything at 0. For the false case, again, Make Rotator. When moving left, we want to turn the character by 180 degrees on the z-axis, so here we can just put in 180. Now if we start the game and walk right, everything is fine, but if we walk left, you can suddenly not see the character anymore. This is actually a sign that the turning is working correctly. You can hit Shift and F1 to get the mouse pointer back and then click on Eject to see what's going on. We can see that the character is now correctly pointing to the left. However, the camera also turned with the character and is now on the opposite side of the tile map. Let's stop the game and fix this really quickly. On the BP player, go to the spring arm, and on the right side click on rotation. We want to set this to world, which will then show up as absolute rotation. And now if we try this out, you can see that we are properly turning left and right and the absolute rotation. Click on rotation. We want to set this to world, which will then show up as absolute rotation. And now if we try this out, you can see that we are properly turning left and right and the camera is ignoring the rotation of our character. But our character still feels very floaty and not fun to control. This is because the default settings on the character movement component are not that great. Open up the BP_player and select the character movement component. Here just look for gravity and set it to something like 3.0. Now if we play the game, you can see that the character falls much faster, but we also need to change the jump power to accommodate for that. Back on the character movement component, look for jump velocity and set this to 800. We can then also set air control to something like 0.7 to make the movement in the air more responsive. And all of these are just some values I found. Through trial and error that I believe make the character more fun to control. One more problem we have is that if we try to walk off the ledge, instead of falling instantly, we just awkwardly walk downward slowly. This happens because of the capsule component in the BP player, and capsules are really nice if you have stairs and slopes, but for things like these they can lead to problems. Luckily though, there's a simple setting for this on the character movement component. Just look for floor and activate use flat base for floor checks. And now we fall instantly, like it is the case with most 2D games. One last setting we want to adjust on the character movement component is the movement constraint. Even if we make a 2D game and only have an input setup for left and right, it could still happen through physics or forces that we are being pushed into the foreground or background. To prevent this, we can go to the character movement component in the BP player and look for constraint. Activate constraint to plane. And in the plane constraint normal, we need to set the direction in which we want to constrain the movement. Again, if we look at the player start, we can see that the green axis is the one which we want to prevent movement in. And this is the y-axis. So on the y-axis, we just set the plane constraint normal to 1.0 to activate it. And now we can be absolutely sure that the character will never leave the original lane. And this is all we have to do to set up the base for a 2D game in Unreal Engine. This might seem like a lot, and yeah, it is a lot to remember, but once you've done this a couple of times, it feels like second nature. However, I actually made a free template that is open source that already has all of this set up. You can easily add this to Unreal Engine and create all of your new 2D projects from it, so you don't have to go through all of these steps every single time you want to make a 2D game. But it's very important that you followed along with this tutorial and did everything at least once, so you can understand how all of these different things work and expand upon them. And as a patron, you can also get 2 more advanced templates that use paper-ZD animation graphs, and there is one version for a 2D 3D hybrid side-scroller and another one for a 2D 3D hybrid top-down game. And now to wrap things up, we can just go into the tm_stage and expand upon our map to make things look a bit nicer. Making tile maps isn't something I'm necessarily great at, and you can just go wild on your end and use all of the tiles we have available here to make a stage you like. I'll add a couple of more layers to add clouds, props, decorations, and other things to dress up the stage a little bit. And this is the small stage I ended up with after playing around with it for a little bit. And I hope you enjoyed this introduction to making 2D. I'm often asked how to use high-resolution hand-drawn sprites. in Unreal Engine to create 2D or 2D 3D hybrid games. But since so far I only covered pixel art in my videos, I never had a good answer until now. Over the last couple of months, I started to look into how to get rid of issues with aliasing and blurriness when using hand-drawn art, and how to create a look similar to Ender Lilies, The Vagrant, Escape from Ever After, or Born of Bread, which are all Unreal Engine games. But I didn't do that research all on my own, and on top of very knowledgeable members in our Discord, the developers of Born of Bread, Wild Arts Games were also really helpful and shared their settings with me. First, we're gonna go through all of the related settings, and I'll give you an explanation of how each of these affects our sprites. And at the end, I'll show you the combination of settings I came up with for my 2D 3D hybrid scene and also my flat 2D scene. Let's get started. I created a new project with Unreal Engine 5.5, but I doubt much will change with these settings in the future, and they should still be valid for a long time. Many of the games I used as a reference were still using Unreal Engine 4, so I was a bit worried this might not even be achievable in Unreal Engine 5. But after trying it with both UE 5.5 and UE 4.27, I didn't really notice any big difference. I then imported a few different assets from Douglas Avila for testing, with the Cobra robot being a free asset and the Toon Medieval Fantasy Pack being a paid asset on FAP. Some of these assets already came with the Paper 2D texture settings applied, but I set everything back to the default values to have the same starting point you would when you just import a new texture into Unreal. In the texture viewer, you can see that all of these are very high quality and have a high resolution, but they don't look quite that nice in-game. On the hybrid side, we can see many issues right away. Even though the edges look quite smooth and we don't see much aliasing, the colors seem to merge together in certain places and we can see clear ghosting or after images. In the 2D scene from a far distance, things don't look too bad, but when paying close attention or zooming in, you can tell that there's also ghosting and things look blurry with the lines not being sharp either. When we switch into the unlit mode here, you can also see that we get visible aliasing or jagged lines around the edges of the character. Let's take care of these issues step by step by going through all of the related settings. The first thing we definitely want to turn off are auto exposure and motion blur. Auto exposure isn't specifically related to the problems with our sprites, but it can make 2D scenes look very blown out and overexposed by mimicking the effect of your eyes adapting to changes in lighting conditions around you. In the project settings, I just look for exposure, turn auto exposure off, set it to manual and the bias to 0.
Imagine being able to build an app with your name on it, just by thinking about it. Meet Base 44, a complete AI creation platform.
Now both of these scenes just have more consistent lighting for better testing. Next up is motion blur, and even though it's getting a lot of hate, it can enhance the look of 3D games. But for sprite-based games, we don't want to use it since it will lead to some ghosting and blurriness regardless of if we're using pixel art or high-resolution hand-painted sprites. We can simply turn motion blur off in the project settings. But even after that, you might not be able to tell a big difference since we still have multiple settings on that lead to blurring and ghosting regardless. Next up, we want to turn off lumen and related settings just to make sure they don't interfere with our testing. For the 3D scene, you could use lumen and nanite if you wanted to, but lumen comes with its own risk of ghosting that might interfere with our tests, and for 2D only scenes, you most definitely want to turn it off. In the project settings, look for dynamic global illumination method and set it to none. Set reflection that might could use lumen and nanite if you wanted to, don't interfere with thing regardless. Tell a big diff project settings. But even after that, you might not be able to tell a big difference since we still have multiple settings on that lead to blurring and ghosting regardless. Next up, we want to turn off lumen and related settings just to make sure they don't interfere with our testing. For the 3D scene, you could use lumen and nanite if you wanted to, but lumen comes with its own risk of ghosting that might interfere with our tests, and for 2D only scenes, you most definitely want to turn it off. In the project settings, look for dynamic global illumination method and set it to none. Set reflection method to screen space, and shadow maps back to the regular shadow maps. Again, you probably won't be able to tell the difference just yet, but we're working towards our goal. Now the next setting is one of the most important ones, and it is anti-aliasing. If you're unfamiliar, anti-aliasing is the most important ones, and it is yet, but we're working towards our goal. Again, you probably won't important ones remove jagged methods available if the default it's also jagged lines, but it comes at a high performance cost, and the temporal part in the name means that it accumulates information over multiple frames. Skeletal meshes, for example, come with motion vectors that allow the algorithm to prevent ghosting to some degree by analyzing the movement. However, sprites do not have motion vectors, and this is what leads to the extreme ghosting we've been wrestling with. It does appear that there is a way to generate motion vectors for flipbooks, but it's a huge new rabbit hole to go down that will drastically affect your workflow, and I don't think it's worth going down. But I'll at least attach a link in the description if you want to read up on it. Also, since Unreal Engine 5.4, I believe we got a new setting in our materials called Has Pixel Animation. It's not intended for sprites, but rather scrolling or animated materials, but we thought that as a side effect it might also work to combat ghosting with flipbooks. And when I tried this a few months back with pixel art, it seemed to have no impact at all. But when trying it again with these assets, it did counteract some ghosting, but it still wasn't enough to make it a valid option. I also thought that bone-based sprite solutions like Spine might be able to counteract ghosting, but it doesn't seem that way, and using their sample project I also got severe ghosting with TSR or TAA. TAA or temporal anti-aliasing comes with similar issues since again it has temporal in the name and accumulates information over multiple frames. This leaves us with none, FXAA or MSAA as the remaining options. MSAA or multi-sample anti-aliasing is a pretty old school technique that relies on detecting edges of geometry. And one of the main reasons it stopped being used widely is that it's incapable of applying anti-aliasing on things such as normal maps or shader-based effects. And since our sprite is just an image attached to a quad, MSAA won't be able to do anything to help us here. And it's also only available when switching from deferred rendering to forward rendering. Okay, so that only leaves us with FXAA or none. With both FXAA and none, we get rid of the ghosting issues and also the colors merging together, which is great. But in both cases, we do get some rough pixels around the characters and some aliasing. I do believe though that FXAA does a better job at offering at least some anti-aliasing over having none. Especially for a 2D 3D hybrid, it also offers anti-aliasing for 3D objects in the background, and while it's not the most advanced anti-aliasing method, it's still better than nothing, and it's actually also what Born of Bread is using. And also Ender Lilies, which is a flat 2D game made with Unreal Engine 4, also offers some sort of anti-aliasing. And due to none of the other methods being a valid option, I believe it's also using FXAA. So what I would do is give players the option to pick between none and FXAA, but have FXAA active by default, and for now I'll also stick with FXAA for the remaining tests. The next couple of issues I only became aware of after messing around with Unity to see how things work over there regarding high resolution sprites. And by default, my zoom scale was set to 1.3 and made things look absolutely horrible in the viewport. So when I figured out that just by playing in a maximized window with a scale of 1 already made the sprites look so much better, I thought something similar might also help in Unreal Engine. We have multiple ways to start and test play our game, and